Hello students, today we have talked about the motion of two bodies connected over inclined plane. So here m2 and m1 are the two masses and the coefficient of friction of this surface is mu2 and this surface is mu1. Okay, this angle is alpha 2 and this angle is alpha 1. So one by one these two objects are solving independently. So let's suppose because these two strings are same, so the tension is same in both. Okay, so if this is in this direction, R2 is in this direction and this is again alpha, so this is m2g cos alpha 2 and m2g sin alpha 2. Okay, so the since m1 is larger, if m1 is larger than m2, so this motion is in upward direction. Okay, so here R2 equal to m2g cos alpha 2 and the frictional force F2 equal to mu to R2. So mu2 m2g cos alpha 2, and similarly in this direction R1 is m1g cos alpha 1 and F equal to mu1 m1g cos alpha 1. Okay, so one by one we can solve for these two expression. That here if it is going upward and this is going downward. Okay, so how can we proceed to find this expression? Okay, so here if it is going downward means m1g sin alpha 1 is larger than tension, so m1g sin alpha minus t equal to your force m1g sin alpha 1. Okay, and if it is going downward then the frictional force is acting upward, so net force is m1g sin alpha 1 minus t minus m1 mu1 m1g cos alpha equal to m1a. Okay, and similarly for this t is larger, so t minus m2g sin alpha 2 minus mu2 m2g cos alpha 2 equal to m2a. Okay, and by solving these two equation 1 and 2 we can obtain for the final expression. Okay, simply you can add. Okay, by adding in these two equations we can obtain for the expression a equal to m1g sin alpha minus m2g sin alpha 2 minus mu1 m1g cos alpha mu2 m2g cos alpha 2 upon m1 plus m2. So m1g is w1, m2g is w2. Okay, you can put w1 or w2 or this is depends on you whether you want to put w1 or if you don't wish to put w1, it is like you can keep the equation in m1 and m2. Okay, so a is equal to this. Okay, and by putting this value of a in this expression to determine the t. Okay, so this is a simple mathematics you can understand by these steps from the notes. And so we come to the final point where after solving we can obtain for the expression for t is w1 w2 upon w1 plus w2 sin alpha 1 plus sin alpha 2 minus mu1 cos alpha 1 minus mu2 cos alpha 2. Okay, and for a smooth horizontal surface mu1 and mu2 assumed to be 0, and by putting these two values 0 we can obtain for the acceleration. Expression for the acceleration is this a equal to w1 sin alpha and w2 sin alpha 2 upon w1 plus w2 times g, and t is equal to w1 w2 upon w1 plus w2 sin alpha 1 plus sin alpha 2. Okay, so here if this is your this alpha 1 and this is alpha 2. Okay, so the angle between these two tension is 180 degree minus alpha 1 plus alpha 2. Okay, and by putting this value in this equation to determine the resultant is 2t sin alpha 1 plus alpha 2 by 2. Okay, so the pressure is nothing but 2 times of pressure is nothing but 2 times of pressure is t. Okay, sin alpha 1 plus alpha 2 by 2. Now our last topic is D Alembert Principle. Okay, so the D Alembert principle is a very important topic. So in order to understand what is D Alembert principle, so the basic concept of D Alembert principle is that the system of forces acting on a body in motion is overall resultant to be 0. Okay, so now come to this point. If this is body and this is, if you apply the force in this direction, and if the body is rigid or body does not have any kind of displacement, so the net force or net force on this point is 0. So if this is a reaction is R is here and M1 is this. Okay, so the R minus M1A on this surface is 0. Okay, so force that is which is assumed to be minus MA is also termed as the inertia force. Okay, so nothing but if this is a body and we can apply a force on this, so the same amount of force in opposite direction is acted on this body. If we can apply force positive F in this direction, so the negative F is in the direction, so the resultant force on this point is 0. Okay, so R minus M equal to 0. So how can we use this concept to solve the problem is this. Let's suppose a man weighing 750 Newton stands on the floor of a lift. Determine the pressure exerted on the floor. A, the lift moves upward with acceleration 2.5 meter per second square, and B, the lift moves downward with acceleration this. Okay, so if this is the lift, okay, if this is the lift, so the for upward motion T minus mg equal to m1a. Okay, so T equal to mg plus ma. Okay, so by solving this equation we can obtain that T is equal to W1 plus A by G. So 750 upon 9.81 and 9.81 plus 2.5. Okay, and by solving this equation we can obtain the final expression for tension, as well as for the case of downward we can obtain the expression for the tension is 558.87 Newton. Okay, now how can if the 900 Newton pressure is the second part of the question is that if 900 Newton pressure is to be exerted on the floor, then with what acceleration the lift should move upward? Work out a solution using D Alembert principle. So in case of D Alembert principle, the net force on this object is 0. Okay, so since the lift is going upward, so the net tension on this body is T minus mg, that is equal to m into A. Okay, so by using this equation 900 minus 750 by G into G minus 750 by 9.82 into A4 equal to 0, and by using this we can obtain A4 equal to 1.962 meter per second square. So this is the basic curve, because if it is tension is T, your mg is this. So the net force is nothing but T minus mg, and if that resultant force is gives the acceleration onto the lift, okay, that is m into A. So by since this is 750 by G and this is your m is 750 by 9.81, this is mass. So by using this equation we can obtain for the acceleration, that is 1.962 meter per second square. So this is the D Alembert principle. Thank you.